In the first video of the chapter Factorization, I discussed the remainder theorem. In this part, I discussed the statement of the remainder theorem, its proof, and the implementation of the theorem in different questions. Now I start factor theorem, and in this part, I'll discuss the statement of the theorem, its proof, and how to implement factor theorem in different question. So let's start. Let's see what factor theorem says. It says if x minus a is a factor of a polynomial fx, then f of a equal to 0. The meaning is very much clear that when x minus a is a factor of the polynomial fx, then f of a actually is a remainder. So we know very well that if any expression is a factor of the given polynomial, then remainder obtained is always 0. And here it is clear that f of a is the remainder. By remainder theorem we understand, and hence if this value is 0, then x minus a is a factor. So once more I repeat, if the remainder obtained is 0, then the divisor is the factor of the dividend. So that only is mentioned here as a statement. I repeat the statement, if x minus a is a factor of a polynomial fx, here fx is being treated as dividend and x minus a is divisor. And if f of a, it means the remainder f of a is 0, then it's obvious that x minus a, the divisor, is the factor of f of x, which is the dividend. So let's observe the proof for this theorem. In this proof, we start with the same usual statement, and that is dividend equal to divisor multiplied by quotient plus remainder. Let's observe the second line. Fx, we know it is dividend, x minus a is the divisor, q of x is another function of x, that is the quotient here, and that we don't know. But one thing we know here, that remainder is 0, because divisor x minus a I am taking as a factor of fx. Again the same usual statement, that replace x with a to make x minus a 0, so that after simplifying it we get f of a equal to 0. So meaning is very much clear that when fx is divided by x minus a and the remainder obtained is equal to fa, it's said by remainder theorem, and if that f of a, that is remainder, if it is 0, then obviously x minus a becomes the factor of fx. Or in reverse form, if x minus a is a factor of fx, then f of a, that is a remainder, will always be 0. Now let's take some examples in which, by making use of factor theorem, we try to solve the questions. So here the first example is to divide 2x cubed plus 3x square minus 11x plus 5 by x minus 2 and check if x minus 2 is a factor of the given polynomial. Here we take the help of factor theorem and we try to obtain the remainder, and we check if the remainder comes 0, then x minus 2 is a factor of fx, otherwise no. Hence, in the expression 2x cubed plus 3x square minus 11x plus 5, we replace each x with 2 and we simplify that expression, and finally we get the remainder 11. And since the remainder obtained is a non-zero number, hence x minus 2 is not a factor of fx. Let's take another example, example number 2, in which the polynomial 2x cube minus 3x square minus 5x plus 6 is to be divided by x minus 2. Now, as I feel I don't need to explain each and every word or each and every line here. The process is very much clear. So in short, we can proceed. So let's see here to make the divisor x minus 2 equal to 0. In that relation, what I had said, dividend equal to divisor multiplied by quotient plus remainder. That we recall always. We don't need to write here because directly we are writing here as reason, that remainder theorem or factor theorem. So to replace x minus 2 with 0, we need to replace x with 2 in the expression which is the dividend here, and we simplify that expression and we see what value we get at last. And after simplification, we find that the value we get of the expression is 0. Hence, f of 2, that is the remainder, comes 0 here. So therefore, x minus 2 is a factor of fx. Let's take another example, example number 3, in which it's given here that x minus 2 is a factor of the polynomial 2x cube minus 3x square minus 5x plus k, and we have to find out the value of k. So this question is a bit different from the first two questions, but let's see all different questions we try and we come to know the way of writing of the solution in this chapter. Now let's observe. It's mentioned x minus 2 is a factor. So since x minus 2 is a factor, hence by factor theorem, the remainder f of 2 must be 0. And here f of 2 equal to 0 becomes an equation where at the left hand side we put the value of f2. In the first line I have put here x, but it has to be replaced with 2. So check the next line and ignore this one. Just a minute. So here I want you to ignore this line. The reason behind is at the right hand side it's written 0, but at the left hand side x is still there. But that can be 0 if x is replaced with 2, and that line we don't need. So let's proceed. The next line is 2 multiplied by 2 cube minus 3 multiplied by 2 square minus 5 multiplied by 2 plus k is equal to 0. So meaning is clear here that big expression at the left hand side represents a remainder, and according to the theorem, since x minus 2 is a factor, hence the right hand side has to be 0. It shows that the remainder has to be 0. And now we simplify this equation, which is a linear equation in terms of k, and we find the value of k, and that comes 6. So this is the answer. The question says find k we obtained, it comes 6, hence the answer is 6. So done, no confusion at all. Now let's take another example, example number 4, which again is a bit different from the first 3 examples explained. So here x plus 2 is a factor of the given very big polynomial. Hence, according to factor theorem, the remainder has to be 0, and here the remainder is f of minus 2. And how can that be? That has been explained in the last few examples. And according to factor theorem, this has to be 0. Hence, let's take f of minus 2 equal to 0, an equation where in fx we put the value of minus 2 for x, and that is equal to 0, and we simplify this equation, and in this equation one unknown small a is there, and by simplifying it we find the value of a, and that comes 4.7. And I don't think any more explanation you need in this example. and this value 4.75 as the value of A finally is the answer. Okay, now you see at last two questions are given for you to solve at home, and see the process with different examples are shown here, and try to write your solutions with the best process. In this video, I discussed factor theorem, and I believe the factor theorem, its proof and its implementation in different questions you could have understood very well. And if you get any query, you can put in the comment box. Thank you very much.